Thank you, everyone. Welcome on my talk. My name is Gabor Olah. The first part is literally on my face. So let's start with some exercise. Who has worked on code before? Who worked on legacy code before? Who liked it? That's okay. So what is legacy code? My native language is not English, so I looked up what legacy means, and surprisingly I found this definition in the Oxford English Dictionary. It says, denoting or relating to software or hardware that has been superseded but is difficult to replace because of its wide use. I found this definition very troubling because it says superseded. So whenever we modify a piece of code, it means that the previous version of that piece of code is superseded. That's why we modify it. So literally it means every code. Difficult to replace. How difficult it is to replace. Sometimes even writing new code is difficult, so what's the measure of difficulty? And because of its wide use. So if it's only used one place, and it's only referred in one part of the code base, it's no longer legacy because it's not widely used, and probably it's not difficult to replace. I doubt that this is true. So what's missing from this definition? In my opinion, what's missing is a piece of software is legacy and difficult to replace if you don't have full information about this piece of code. And what's the thing that you most probably miss, because you have the source code, and this is everything you need to know. This is everything the computer needs to know. So if you are a computer, you don't miss anything. But if you are a human being, you miss a lot of things. For example, the mindset, how this code was written, what was in the developer's mind when it was written. And this is a very important thing, and we will see why later on. What's also missing is the context. What was around when this code was built? What was the team spirit? What the team was doing? What were the business perspectives? What were the priorities? What were the requirements? How these requirements were propagated? Did they use, for example, proper version control or a ticketing system? Or it was just somebody shouting that, do the change, and that's it. So context is also important, and it's not written in the source code. Sometimes you find this in comments, very dangerous place, because sometimes they are not updated. So comments may refer to a piece of code that's already not there. It was a previous version. But what is this, for example, fix me or to do, or a whole litany of these are the things that I was thinking about, and these are the things that should have been done, but I haven't done it, and so forth. It's very useful information. You should read it and then evaluate it. And what's also missing are the assumptions. I've never ever met with any business analyst who were able to provide me all the decisions that I needed to make during coding. I needed to make decisions. For example, this edge case, what to do with this edge case? I don't know. I have two choices. Ask the business analyst, what's the business when, for example, there are no entries in the database, or there is no database connection. If I tell the business analyst that it's a case that there is no database connection, that person will freak out and I will cause more trouble. So I need to make a decision, probably raise an exception. It's just postponing the problem to the handler of the exception. So these assumptions are also missing from the code. What's also missing is what the developer was thinking about and dismissed. This is how I will code it. This is a nice looking algorithm, but probably it's too overkill for my use case. So I will choose a more simpler algorithm that will hurt us in probably 3 years down the line. So it's really, it's again something that is missing. And this is what we need to figure it out. So my definition of legacy code is a code that is either older than half a year. Half a year is enough to forget a lot of things that was in my mind, especially when things were quite quick. Or, not and, or. more than 5,000 lines. I find that a couple of thousand lines is probably enough to memorize or remember a lot of things in it. But if it reaches a certain threshold, it's not an exact. 4,999 is just enough to be legacy, but around 5,000, it's a lot of code to remember. And believe me, it's really a lot of code to remember what were we thinking, especially in a terse language like Erlang. There is very little boilerplate, and boilerplate code counts. Probably in a C# project that starts with 5,000 lines of code for an empty project, for a good reason, that's easy to remember. And please don't lie that it's just C#. Try to create a mix project for Phoenix. How much code is automatically generated. That's also code. Or it was developed by somebody else. And this qualifies for me almost all code out there. I wrote very little code. I worked on very big software projects for a long time, but I wrote very little code. So, especially compared to all the code out there. So, if I didn't write it, I have no idea what was in the head of the other developer. So for me, it qualifies as legacy code. One thing that is very important. Let's stop here for a moment. I did read the book called Work with Legacy Code by Feathers. And he defines legacy code as code without tests. I don't agree with that. Even code with tests is just as legacy for me. Code without tests is really difficult to understand, but for a completely different reason. So just the lack of tests is not enough. And there is again a very important difference. One is that we need to figure out whether the code is something that I don't understand yet, or is just bad. So bad code and code that I don't understand is not a one-to-one correlation. Just because I don't know it, it doesn't mean that it's bad. Just because it's bad, it doesn't mean that I can't understand it. Okay? So there is a huge gray area in between. What I usually hear people describe legacy code is that it's spaghetti. How I usually describe spaghetti code is imagine a bowl of spaghetti that's starts to dry. It wasn't even oiled. And you try to understand it and you start pulling one thread and the whole ball comes. So, okay, so give it up, try another one and the whole ball comes. And wherever you try, the whole context comes all the time. For me, that's spaghetti code. It doesn't mean that it's not possible to understand. You just need a fork and a knife, but eventually you can understand it. Another term that they usually use, obscure. Obscure, sometimes it happens. Sometimes I just haven't spent enough time to understand it. Or somebody else's mindset is completely different. What qualifies obscure to me is sometimes completely different than what qualifies to somebody else. Back at university, I had a classmate who was really fond of Haskell. And he did these brain teasers expressing very, very difficult algorithms in Haskell in one line. Sometimes the line was very long, but it's not the length of the line that made it difficult. It's the dot operator, which is the compose operator. If you ever checked Haskell, it's a very dangerous thing because it just composes two functions. And since you don't need to name which parameter where it composes, you need to understand it. And when you have dot, 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 it's really difficult to figure out what's going on. But it wasn't obscure to him, it was completely obfuscated. I couldn't decipher it, I was not clever enough. I admit I was not clever enough for that kind of code. Sometimes they call it messy. Yes, sometimes it happens. Especially when deadlines are close and things get messy in real life. Or tangled. This actually resembles a proper software system, especially that there is a man here who tries to untangle it. Very dangerous job because most probably it's not unpowered. So it's a bit of live coding. We were talking about these adjectives, and when I ask, so what's good code? And people usually say it's a beautiful code. Do you know what beautiful falls into which category? It falls into the category of aesthetics. This is again from the Oxford Dictionary. A set of principles concerned with the nature and appreciation of beauty. And very importantly, aesthetics is a branch of psychology. Not engineering, psychology. It has nothing to do with psychology. It is like art. Art is an aesthetic phenomena. And just to demonstrate it, here's a nice picture. Somebody thought it's really nice because it's in our stock photo collection, but I don't really like it. It's a yellow, green, lime, but some people like it. So just because I don't like it, it doesn't mean that it's a bad picture. You might like it, I don't. Does it mean that it's a bad picture? No. If you don't like it, doesn't mean that I should change it? No. Or if you do like it, does it mean that I need to accept it? That this is a good picture? No. I need to accept that you don't like it. So when you look at code, be sure that you're able to distinguish your feelings, your attitude from your value judgment and what's real and what's a fact, because facts fall into the engineering part of computer science. So if not aesthetics and not beauty, most probably it's software metrics. Those people who live long enough might remember the early 90s when software metrics was a thing, was the thing to save software engineering and try to tackle this problem that what's beautiful, and they try to figure out what kind of metrics correlate with beautiful code. So probably they asked a lot of people, mainly university students, what's beautiful code? And they categorized it and they tried to figure out that university students prefer very short code because it's easy to understand. They don't like complex algorithms, so low cyclomatic complexity is preferred. So software metrics is something like this diagram. Makes no sense in isolation. So don't try to find the sense in it. It's just a diagram. It has a bunch of numbers. It represents something. Does it mean that if my code has this kind of metric, that it's bad or good? What does it mean? And we don't know. It's still an open research project. So we can't really find an algorithm that describes this is good code, this will be easy to maintain, whatever. Because otherwise, if we were managed to do it, then probably we would use it everywhere. And to demonstrate this, I brought some battle stories, actually 3 battle stories. And the first one is a module too long. I worked on a commercial product, I will not name it, the company shall not be named, and hopefully there won't be any value judgment in it. The module too long anecdote is about an Erlang module that was developed as a dictionary or to execute business validation steps for a message. A message came in, and these were the things that the business wanted us to validate for that message. And the business was really eager validating a lot of things. So that module grew over 1,000 lines. And there was an engineer there who didn't like that because it was a long module. It fall into the category of too many lines of code. That's a metric that's easy to measure. Most editors can do it, or a Unix command. So if you find the long modules, obviously these are the ones that are complex, so they need to be simplified, because a simpler code is easier to understand. So what he did is looked into the code with a very good intention, and found that, yes, there are a lot of requirements, and there are some duplication in that code, but what to do with the duplication? Minimize the number of duplications, the dry principle. Don't repeat yourself. which is a very dangerous principle. Look it up on the internet. There are many objecting views how to apply it. And that's a sign. If people are objecting or have contradicting opinions about a principle, then it's a dangerous thing. Not necessarily a bad thing. So what he did is found the duplication and starting creating library functions. That's how we called it. It was put into a lib module, and the main part called the lib module. And it turns out that there were no reasonable abstraction to create a lib module. So the end result, what the next generation of programmers needs to face, because this is not a blaming game. You inherited that code, this is what you need to deal with. How you deal with it, that's a different question. But the next generation of programmers who open the main catalog of steps that you can execute will face that I want this step, which I should be able to understand isolated, has two parts. The first part is in this module, and the very last call goes into the lib module. So whenever I opened this module, the first one, I always needed to open the second one and read one function in two parts, the first part and the second part. Not generic part and the concrete part, but first part and second part. It was annoying. Annoying because there was no reasonable way to justify why I need to read one function in two places. But the reason was that there was a really good intention getting rid of the duplication and making a module shorter. So now we have two shorter modules. Obviously they are shorter, but they are not necessarily simpler to understand. So the assumption is less cognitive overhead. Unfortunately, we have a blue cast, so this is red, less cognitive overhead. That was the assumption. It's not true. It's more cognitive overhead because I always need to read it in two sections instead of one. There is another metric like cyclomatic complexity, which measures how many decision points are made in an algorithm and measures these decision points. So we had a problem to map certain fields in a record to another value. So the idea was that if we could describe this mapping in a table, if this is the incoming value, map these fields to this value. This is exactly what it does. Get one reference point. If it is A, apply these overrides. If it is B, apply these overrides. Notice that these are the same values, but these are still overrides. And if it is C, apply these values. So far, so good. Very easy algorithm, very difficult to make it wrong. And this correlates one-to-one to the business requirements that we needed to make. The problem is that instead of having A, B, and C options for F0, we had about 26. And instead of overriding two fields, eventually it grew to 3 or 4, or sometimes more complex, like this one, that if it was A, then we needed to check another field and do different kinds of overrides. And notice that here is another value which is the same. So it was all over the place. And that function grew to 250 lines, with case statements and case statements, and sometimes another case statement. It happened. But the actual logic was, if you have a message of this type, type B, you went to this close, and in 2 lines, you could understand what that function did. Really important. Step 1, find the case close that you need. Step 2, read the overrides. Really easy. If you were unlucky and have A, you needed to do 3 steps. So an engineer saw this 250 line long function. By any measure, it's a long function. I agree, it's a long function. It's not complex, it's long. Cyclomatically complex because it has a cyclomatic complexity of 3, because there are 3 cases inside. So it's difficult. So So mapping values, no algorithms, too many requirements. Unfortunately, we couldn't just remove the requirements, not handling 26 different kinds of messages. We needed to handle 26, so there were these kinds of things. Sometimes the business requirements can't be changed. Sometimes it happens. And there were some duplications. So what an engineer did to make it simpler, meaning shorter, because shorter functions are easier to understand, obviously, he did a refactoring. It's very trivial in Erlang. If you have a case statement with clauses, you can transform it into function clauses. So you removed a case statement and put it into top level. You removed one nesting. And if you have this kind of thing, you just need to remove it further. So what he did is wrote a self-recursive function that did all of this without cases. Each function was very short, 2 lines long at most, or 3, and did very, very little logic, just defined the overheads. But sometimes it called itself recursively, and sometimes again. So now we have about 50 clauses, 110 lines long, so it's definitely shorter. But now we have a 110 lines long self-recursive functions with 20 different clauses. How easy it is to understand? The problem is, if I have message A, I need to understand 110 lines. If I have message B, I need to understand 110 lines. And it repeats itself. The next generation of programmers dread this piece of code because it's so difficult to understand. The intention was good. Make it simpler, shorter, so that you don't need to read 250 lines. In reality, what he missed is that you never read 250 lines. You only read probably 5 and do a search. It was easy. The context was remove the nesting duplication, and he chose algorithm for brevity. So it was now written for a computer, not for a human being. The computer had no problem with the case or no problem with the recursion. It always completed. Oh, and by the way, now we have a 1,000 lines long test that tests all the cases that everything is the same as previously with the case, which was trivial. So now it's tested. So it must not be legacy, according to Feathers. And it must be easy to refactor, because refactoring 50 clauses is easy, because it's tested. And the test coverage is 100%, both by line and both by logic, so it's easy. And my third one is no deadline. It's a very funny story, very sad and funny story at the same time. So everybody complains that deadlines are bad, that's why we write bad code. So imagine an engineer whose problem was change the timestamp format in the logs. Because we had a system that half of it was written in Erlang, half of it was written in Java, and the customer wanted one single timestamp format. They preferred the Java one. So the Erlang guys needed to do some modification. What he heard, that engineer, is change the timestamp. It was a low period, so there were no deadlines, basically. It was 2-3 months long, and he knew that he could fit in, any kind of modification during this, inside this period. So no pressure from project management, good software practices was followed. He wrote a really beautiful piece of code. By any measure, it was beautiful. It was well tested, it was everything. What he did, he re-implemented the Unix date utility in Erlang with YAC and all the parsing and everything. It was completely optional how you want the case statement. So his mindset was, if it changes once, it will change again. So you don't want to touch the code again. So it needs to be generic. So what he heard from this requirement is a customizable feature. What he failed to do is ask the business guys, why do you need this change? And do we need to change it again? He didn't ask for it. And the answer would have been, we need it because the 2 log formats needs to be the same, and we will never change it again. But maybe we need another variant, so 2 cases. He introduced 3,000 lines of code and 1,500 lines of test cases. for a 5-line case. The next generation of engineers need to figure out that when it is used, and we don't know because the variants are deployed for the customer, and now it's that configuration option is exposed to the customer, so it could be anything. Now you need to maintain it. It's called only once in the whole code base. Is it 10 minutes? No? So it's called only once in the whole code base. Is it easy to understand what's going on and whether I can change it? No. I could change it because I know the business requirements and we control the release. But I'm not changing it because it's already working and it's testing, so why bother? Unfortunately, the next generation of engineers needs to maintain another 3,000 lines of code, and I needed to change the Erlang now command probably 100 places in the test cases. That's how I realized that this is a feature now. I changed the test cases, now it will run for the next 20 years. This is how legacy code is made. Good intentions, good engineering. Sometimes bad code is generated because the deadline is harsh, the piece of modification goes into different parts of the software where it would have belonged. It happens. So bad code is a different thing. But legacy code are all of these. And when you join, you only know that we have a feature. You don't know what was going on. Oh, and by the way, the developer did this because he wanted to learn parsing and everything in Erlang. And nobody told him not to do it in the project. This is probably a good point to distinguish software engineering and art. If you think that code is artistic, I agree. Go home and practice it. If you are working on a commercial project, please don't create art. I'm not sure where on Earth, but I'm pretty sure there are museums that have chairs solely as an art form. If you think that that is a piece of art, then software engineering should be art. So probably it's better not to do it. So what's the correct mindset to tackle legacy code? And this is, I think, where most developers fail. That, oh, I need to work on a legacy code base, so it must be really difficult and the code must be, I will not say it. But if you are humble, that just because you are right and you know the correct answer, it doesn't mean that you need to push it through. That developer who knew the correct answer that 250 lines long function is difficult, he pushed it through. He didn't listen. He was very convinced that he was right. So be humble. Work together, not necessarily in this fashion, because probably it is very annoying to have 5 people talking around you. But whenever you are in doubt, and if you are humble, you will be in doubt whether your modification is good, whether your modification is worthwhile, then talk about it. Get others' opinion. Not necessarily change your opinion, but at least talk about it. You should see another option. If you only have one option, you haven't considered all. There must be another option out there. And if it turns out that your solution is the best one, even though it's really messy, then that is the solution. That function, 250 lines, was created not because it was a good solution, but because that was the only solution feasible at the point of time. The whole thing belonged to another place in the code. Actually, it's not even an Erlang application that should have done that change, but the other application couldn't do it for different reasons. So talk about your solutions. Work together with other people. Figure out whether they could live with that or not. When I wrote it, almost everybody in the engineering team could live with that change. When the next generation came in, they throw it out because it was not tested and it was long. They didn't bother asking why it was not tested and why was it long. They saw an engineering challenge, make this code more beautiful. And they had time to do it. Be patient. Yeah, sometimes you need to be patient. Not everything can be solved in a matter of hours. I'm really surprised when I hear, for example, on the internet usually that, oh, we sat together this weekend and programmed the whole Uber. Okay. The whole of it, or just the proof of concept that created everything that is now present, but it wasn't when they did it. Not that I try to defend Uber, but it doesn't really matter. But not everything can be solved in a matter of hours or days. The longest bug hunting I did was 2.5 months long. It was not easy to find. We went from application layer to Solaris kernel during the process. It was really fun, tough but fun in the end, very, very satisfying to solve. So be patient, it pays out. Be professional, all of this. So I don't think that we need to say it. Don't be children, don't let your emotions drive your coding. The next generation will not thank you. So what tools we can use? First of all, we need a process. And the process should be that first you understand what you need to do. Then you verify and refine that your understanding is correct. And third, you do the modification. If you change the order, most probably it won't be that good. So what to understand? First and foremost, the requirements. If you don't understand the requirements, don't even start coding. Just because coding is fun and rewarding, it doesn't mean that it substitutes understanding what you need to code, especially if you work as a professional developer. If you are at home, please do whatever you want. Please enjoy it. You need to understand the application structure, the static structure of the code, the dynamic structure of the code, and the data model, obviously. These are quite obvious things. This is how you understand software. My recommendation is to go analog. Use a piece of paper and a pencil, probably. You can use pens, but it's more difficult to erase, though there is an erasable pen nowadays. It comes from Japan. Thank you, Japan. How to understand the code? First and foremost, read the manual. Or read any docs that you can get. If it's outdated, the better. Because now you understand how it progressed. What's the difference between the code? Read the code. Actually go through and read it. Get the piece of paper, write down what you have read, probably draw diagrams because diagrams are more condensed information than text. That's why I recommend a piece of paper instead of writing it in a org file or whatever. I'm an Emacs fan and I tried org, but it's not the way how you understand big software. It's diagrams, condensing information. Write down your questions. Don't just let it go through. I don't understand this piece of code because it's complicated. Why is it complicated? If you write it down, you will not forget answering that question. It might be very useful. And your colleagues will thank you because now you have a piece of paper that they can borrow and photocopy and they can depend on. Believe me, it happened more than one time. And don't forget, ask questions. You can use logs. Once you have an understanding from the source code, now you think that you understand what's going on, use logs to verify it. How to read logs? First of all, read it. Don't trust a fancy stack like Elasticsearch and the whole Elk stack, because it digests your logs for you. You can't really get a grasp what that system is doing if you are reading something that is not produced by the system. And it's really important. Read the logs. Pay attention to what's not there. You have read the source code. You think that this log message should appear in the logs. Why is it not there? Investigate it. Refine. Check the timings in the logs. Check the timestamp. We heard in the keynote, times is the enemy in computer science. Yes, it is. But it's really the enemy when you read logs. How many times you missed a millisecond of delay, and that's the key. That it's not a millisecond. You assume that it's a millisecond, but it's a minute later. It's far away in textually in the logs. If you have more than one log, draw a timeline. Merge it together. I like analog. Now this is a point where probably you can get better results with the tool. I mean, less erasing. And check how whether the entries are unique. If you have an entry that's really annoying, then try to filter the logs manually, preferably. Tracing. If you can access the system, you can use the built-in feature of tracing in Erlang. It's a very useful tool. If you don't know what tracing is, then I really recommend Erlang in Anger. It's a short book by Fred. Thank you, Fred. And it's a really useful one. Learn it. Use it to your advantage. If you want to learn it in a more hands-on manner, then I can recommend our tutorial at Code Elixir London. I myself will be responsible for that. So when to trace? When you have access to the running system, it's really important. You can't trace if you can't have access. Once you have any kinds of access, it's really possible to get the trace output. You can trace to a file, you can trace to a share, you can trace to an open port. It's all possible. Use it to your advantage. You can use the built-in trace, you can use tools like DBG, you can use tools like Redbug. There are a variety out there. There are even front ends for it. Please use it to your advantage. But another question, when to use it? When you have a theory to validate, it's really important. I think this function is called only once when I run that piece of feature. If it's called twice, then something went wrong. Your understanding is not correct. Refine your understanding. Or when you have zero idea what the hell is going on. This is usually the case when you are trying to figure out the entry point to a module. Not to a module, but a piece of software. I don't know who caused it. Use tracing. Trace for that interface that you think is the entry point. If it is not, remove the trace, trace for another one. Try to figure out what's going on. Tracing is is like an art form, because you need to know how much you need to trace. Sometimes it produces a lot of output that's just noise. So that's why I really recommend, have an idea what you are tracing for. And then, now you have an understanding, modify carefully. And notify that testing is a completely orthogonal thing. I'm not saying don't test. Please test, write tests. But if a code is not tested, it doesn't mean that it's bad. It means it's not tested. It's more difficult to understand. It's more probable that if you change it, you will change it in a bad way. It's not guaranteed, no safety net. Testing is safety net. So put as many safety nets as possible, but only modify the code, only change code, write new thing, if you do understand how it will run. So as a summary, realize the difference between bad code and the code that you don't understand. This is important. Be humble and professional. If you have a positive attitude to any piece of software, you might find gems in it. Like I did find the very old software from Ericsson, a piece of gem that is now open sourced as gproc. It's a beautiful engineering part. Nobody ever dared to touch it, it's so complicated. But it's beautiful, it works. Nobody ever needed to touch it because it worked. But you need to look for it, you need to be positive. Understand before modify. If you have a function you've never met before, don't even touch it. Spend another hour or so and try to understand it. And use all tools available, even pen and paper. Thank you very much.